This is the homework helper for Chapter 14, Section 1 in the 8th grade workbook, Polynomials. Now, the top 6 questions are all asking me to do the same thing here. We're supposed to determine whether the expression is a monomial. So a couple things we're looking for. It's got to be one term. One term implies no addition, no subtraction. You can have multiplication because multiplication joins things in one term. You can have numbers, you can have variables, but your exponents all have to equate to positive exponents. So let's be looking for those things here. So if we look at number 1, we've got negative 135 x to the 5th. So there's no addition, no subtraction. It is multiplication. I do have numbers and variables, which is okay. You can have just one, you can have both. And the exponent here on x is positive. So yes, this is going to be a monomial. If we take a look at number 2, we've got 2.4 x to the 3rd, y to the 19th. So no addition, no subtraction. Those are all joined by multiplication, which is allowable. Then here, looking at the exponents are all positive integers. So this one is also a yes. If we look at number 3, though, quickly we see in number 3 that we have a division sign. And that is not allowed. So since we found one thing that doesn't work, it's out. That's a no. One more, number 4, but the top 3 are to the 1/2. So we don't have addition, we don't have subtraction, that's okay. What we do have here, though, is an exponent that's not a positive integer. My exponents all have to be positive integers, numbers like 1, 2, 3, 4, 5, 6, 7, 8. Half is not one of those. So this is not a monomial. Now in 7 through 12 what they're asking you to do is classify each expression as a monomial, a binomial, a trinomial, or not a polynomial. Monomial has one term, fits all the rules that we just saw in the top part there, no addition or subtraction signs. Binomial is going to be 2 of what we saw above, and so that means it's going to be connected by 1 addition or subtraction sign. Trinomial is 3 of what we saw above, so 2 addition or subtraction signs creating 3 parts. Not a polynomial means it's going to somehow violate those rules of monomial somewhere in that expression. So if we take a look, for instance, at number 7, negative 8.9 times x times y, that's okay. But then it's plus 6 over y to the 5th. Well, the fact that this is division is a problem because, again, terms can only be joined by multiplication signs there. So that's not a term there. Since that's not a term, this one is not a polynomial. If we look at number 8, you've got 9/8 a, b to the 8th, c squared d. So it's all one giant term, so it would be looking like a monomial, what we saw above here. We look at the exponents here. We see all of our exponents are positive integers. A and D, since they don't have anything on them, would be exponents of 1, which is fine. There's no violations here. 9/8, yes, there is a division there, but if that's in the fraction. It's not actually giving me something that's not allowable here. So this is a monomial, just like we saw in 1 through 6. And then in number 9, you've got a couple addition signs there. It's creating 3 distinct terms. So it would be looking to be a trinomial. We just want to make sure we don't have any violations there. This one, the exponent is positive. This one, the exponent is positive. They're both integers. This one doesn't have anything, but it's just a plain J number, which is allowable. So that one fits the billing. So this is a trinomial. All right, let's go ahead and take a look at this bottom part here. 13 through 18, finding the degree of the polynomial. So what they're talking about when they're finding the degree of the polynomial is they're really looking for the exponent on the variable that is the largest. The degree is helpful for a couple things. We can use the degree to help us identify terms that we can combine. If we see something that has a degree of 3 and something else that has a degree of 3, meaning 2 exponents that are 3, there's a chance that if they have the same variables that we can combine them. It's also helpful to identify the number of solutions a polynomial which is going to have, which we'll be getting there soon enough. So if we look at number 13, for instance, we've got 7 minus 14x. Well, if we look at the x here, there's no visible exponent there, so the exponent would, of course, be 1, as you know. Since that's the biggest exponent here, this is a first-degree polynomial. If we look at number 14, again, looking at the exponents, a has an exponent of 1. Again, no number there, that's why it's 1. Here, a has an exponent of 2, so that's the biggest one so far. And as we go to the last terms, a has an exponent of 3. Again, this division here is it's a fraction, 6/7, so the division is allowable. That's okay there. Since the biggest exponent here is 3, this is a third-degree polynomial. One more here, 15, 7w minus 16u plus 13v. All of these here have no visible exponent, so the exponent on all of them is a 1. Since they're all 1, that means this is a first-degree polynomial.